Chapter 18, Electrochemistry. Pulling the plug on the power grid. Electricity is generated at central power plants. Some of them are hydroelectric, some of them burn coal, there's nuclear power plants. And then it's distributed to your house through the power grid. And there have been some situations where, something happened to the power grid and the whole East Coast lost power and stuff. But the power grid is that system of sending electricity to the consumer. Average U.S. household uses about 1,000 kilowatt hours of electricity per month. And for some people, the idea of disconnecting from the power grid is really appealing, to just be self-sufficient, right? And that's becoming a lot more viable. One option is solar panels. Now, just having solar panels on your roof does not disconnect you from the power grid. It's just that you are generating electricity through the solar panels and feeding that back into the grid, but you're still connected. In order to disconnect, you need your own bank of batteries to store that electricity so that it's there when you need it at night, because at night your solar panels aren't doing much. Another option that's under development is small fuel cell power plants. And there's a lot of problems still to be worked out. Okay, this is not going to happen next year, but they're working on it. And so they have created fuel cell power plants. They're about the size of a refrigerator that can power a household. And so that's pretty cool. And they use things like hydrogen and oxygen, and they generate water. And so they don't produce a lot of pollutants or anything. They will generate heat because, as we learned about the heat tax, anytime you have energy transforming from one form into another, there's a heat tax and heat will be generated. Well, that heat can be captured and used. You can use it to heat your home or to heat hot water, so that you don't need a hot water heater. So there's some really neat things coming up with that.
You don't need to heat hot water.
Right, you don't need to heat the hot water. Although if you don't keep heating it, it won't stay hot. But thank you for that point. So what is a fuel cell? Fuel cells are based on oxidation reduction chemical reactions. They're really efficient, they produce less pollution. So that's pretty neat. This is a picture of a fuel cell. It's about the size of a refrigerator, so you could imagine having that in your garage and powering your home through that. There are also fuel cell cars. These are not on the mass market yet because where are you going to find hydrogen and oxygen to power your car, right? That's one of the problems. But the hydrogen-oxygen fuel cell is one that is commonly employed, and it uses the reaction between hydrogen and oxygen to form water. So, there aren't any nasty byproducts like you get from burning fossil fuels. So how does this generate power? We know that if you have hydrogen and oxygen gases mixed together and you light a spark, what do you get? Kaboom, right? You get an explosion. That's not real useful, but you can see that there's energy available there. So what happens is, when hydrogen and oxygen bond to form water, they form covalent bonds, right? Sharing of electrons. But those electron pairs are not shared equally. Oxygen's more electronegative than hydrogen, and so it hogs the electrons. So in effect, by forming the hydrogen-oxygen bonds in here, where here you had hydrogen-hydrogen and oxygen-oxygen, when you form those polar covalent bonds, the oxygen now has more electrons than it did before, and the hydrogen has fewer electrons. And so we can say that oxygen has gained electrons, and it has been reduced. So what happens in the hydrogen-oxygen fuel cell is we separate the hydrogen and the oxygen, and we force the electrons to travel through a wire to get from one to the other. And that generates electricity.
Is that hydrolysis?
It is not hydrolysis. It's actually the opposite of hydrolysis. Hydrolysis is passing an electric current through water and breaking it apart into hydrogen and oxygen gases. So it's actually the exact opposite.